Okay, so the question is, using the TI-89, how do you use a when statement to put this function into the calculator so it will be graphed for you? Okay, here's sort of a trick for remembering the order. First off, you need to use something called a when statement. And a when statement requires 3 inputs. Okay, so the first input here is a domain, sometimes called a condition. The second input is the function that is graphed when in the domain. Okay, so sometimes you could think of it this way: whatever x values are in this domain here, those x values go with this function only. Okay, and then the last thing is the other function for x values not in the domain. Okay? So that's how it works. Sometimes I think it's to your advantage, write it out first on the piece of paper, then attempt to type it into the calculator. Okay? So let's do that. So when, okay? Well, here's where you start. You start with this function here. This domain here. That's what goes in first. Okay? Put a little partition here so you can see things clearly. So we start with when the domain is going to be x is greater than or equal to 1, comma, and the function we're going to graph when we're in this domain is this function. We're going to graph x squared, comma, x squared, comma, and the function we're going to graph when we're not in this domain, when we're outside that domain, this is the function we're going to graph, so we just write 2 minus x. So this expression needs to go into y1, and then it can be graphed. So if you enter this in the calculator correctly, you end up getting something like this. The line 2 minus x looks like that, and then it stops here because it's only for, we're correct, x less than 1. So there's a hollow dot. But then the parabola takes over and fills in that hollow dot, and it continues up like that. So this is the x squared part of the graph. Here's the 2 minus x part of the graph. And you can see how all these x values here are x's that are less than 1. Sorry, just less than 1. And all those x values over there are the x values that are greater or equal to 1. And for that, we use the parabola. Okay. Okay, so let's consider this function that has, this piece of this function has 3 different functions that are put together into one, so to speak. We can use a when statement within a when statement to graph something like this. Okay, and here's the thing you want to realize. We'll start off like we always do. We'll say, all right, well, y1 is going to equal when. And the first thing that goes here is the domain that you're going to use for the first function when that first function is, we'll say, true, right? So our first domain here is right there. X is less than or equal to 0. And when that domain is true, in other words, when we pick x's that are less than or equal to 0, we want to graph square root of x. Okay. So I'm going to partition this the following way. Actually, let's be careful. I'll do it like that. Okay. And what I want you to realize now is that if x is not less than or equal to 0, in other words, if x is greater than 0, then we make it down into this second part of the piecewise function. It's the only way to get to either one of these guys is if x was not less than or equal to 0. Otherwise, we would have just done rad x, and the answer would have been whatever it was. Okay. There's one small problem with this, but we'll fix it. All right. So now the next thing is, what do we do next? Well, when, and then we're just going to look in here at this function and notice the following. Okay. Here is the domain we're going to use first. That's going to be the domain when things are true. So I'm going to say x is less than or equal to 3. And you'll notice I left off the 0. Like I said in previous problems, we would not have made it into this red part of the piecewise function unless this were true. So automatically it's implied. If we're down here working, we don't have to worry. We know x is already greater than 0. Otherwise, you never would have made it out of that domain. Okay. Well, when x is less than or equal to 3, we want to do 1 plus x. And then if that's not true, we want to do x squared minus 10. Okay. Make sure you close parentheses twice. Now, here's what I was saying. I think to make this problem a little more interesting if this had been the rad of negative x. Because we know that for x values less than or equal to 0, the rad of x would be an imaginary number, which we're not graphing in this case. So we're going to make it rad negative x, and I'll make the problem a little bit more interesting. So a picture of this might look like, here's that rad negative x, which is defined for all negative numbers, right? You think about numbers less than 0, and you put them into the rad of negative x. You would negate them first, they become positive, and then we can take the square root and get back y values that are real numbers. The next thing is just the line 1 plus x, so y intercept of 1, and we go up to 4 when x is 3. And then lastly, you have that parabola that's starting at, if we plug 3 in there, 3 squared is going to be 9 minus 10 is negative 1. That's going to be a hollow dot because it's not equal to it. The parabola goes up like that. This dot was solid. Let's check the other ones. This is going to be solid, and that's going to be hollow. Okay. All right. So here's a challenge problem for sure. We can start these problems by asking ourselves how many whens we're going to need, right? So every time you know that the first when takes care of the first two, right? But then once you add this piece, you need another when. And then you add this piece, another when. And this piece, another when. So for this problem, we should be able to get it done in 4 whens. This pretty quickly, because you know we're going to start up here. This is going to be the first thing to go into our function, and this is going to be the second thing that's going to go into our when function. So we'll start this. We'll say f of x equals when x is less than negative 10, do the absolute value. Now, in our calculators, it's ABS. You might have noticed that. You can go to catalog, and it's the first thing that usually comes up. What do we have? We had x minus x plus 12 minus 1, comma. Now, here's where we get into a little bit of trouble. We've got to think a little bit. If we're going to make it into any of those functions, the question you should ask yourself is, what do we know about x? Well, we know we can't make it to any of these unless this statement up here was false. So since you know that statement, that x is less than negative 10 is false, for all of the following statements down here, this is true. X is greater than or equal to negative 10. That's what you know. All right. So what does that mean? Well, if you look at this inequality here, it means that only part of it is necessary. You only need to write that thing. Because we already know that x is going to be greater than or equal to negative 10 because this top statement was false. So this part of the inequality is unnecessary. So when we start our next when statement, we can start it like that. We can say when x is less than or equal to negative 4, comma, well, when that's true, I'll use this function, square root of negative x, and here's where I better be careful. So we need now another when. If we think about it, we know what's true if we got to any of these functions. The only way to get to any of those functions is if this statement here was false, right? So for all of these statements, we know that x is greater than negative 4. Now, for those of you looking for a shortcut, like how can I sort of figure this out by just looking at things, there you go. There it is, right? This is sort of the next part of where we're going to be, right? This is the part we didn't make it into that. So that's going to be our next when statement. So I'll make that in red. So it's going to be comma, when x is greater than negative 4, I don't need to write that because it's already implied. Here we go. We'll use this function here when x is less than 0. So that's going to go here. X is less than 0, comma, x plus 2 squared minus 3. Okay. When we start to think about our next when statement, just ask yourself, what did it take to get to these two things, right? You wouldn't have made it into these two functions if x, or if this part wasn't false. Or put it another way, x had to be greater than or equal to 0. Okay? So, here we go. This next when statement is going to be when x is less than or equal to 2 pi. We know we're already here. We're in this part. And when that's true, we're going to do the sine of x. And if we're careful, we can see we have 4 whens, so we don't need another one. Well, if that wasn't true, if this didn't happen, then clearly x was greater than, this is supposed to say 2 pi. We would go with 3. And then just count your parentheses and make sure you have enough, right? So you have 1 open, 2, 1, 2, 3, 4. So 1, 2, 3, 4. However many closed you have and opens have to match. So your graph should look like something like this. Here comes that square root negative x, and then it stops at some point. And with a parabola, it does this. And you've got a sine x graph. And you've got that. And there you go. So let's consider this function that's been given to you. And the question might be, what are the meanings of all these else's? Well, if this is true, we would do x squared. If this is false, then that's how we get into this lower part of the function, which means that this outer else had to be x is greater than 0. That's what that's saying. Okay, so then you sort of come inside and look at this. Now let's just fix up these brackets a little bit. These brackets really should go kind of like that. Would be better. Okay, well, you'd come inside, you'd look here, and you would say, hey, is x less than or equal to 4? If it was, you would do this function. If it wasn't, if this were false, then you'd go here to this else, which means this else must be x is greater than 4. Okay? And if x were greater than 4, you'd come inside one more time. You'd say, hey, is this true? Yes, it is. You would do this function. If it wasn't, then you'd go here and you'd say x is greater than 7.